Uh, Hello, welcome back to the continuing lecture. And uh, it could, this could be for both, uh, time value of money or, uh, uh, well, as far as it is about time value of money, it can apply to any class. But today's topic is optional. Okay, it's an optional topic. Why? Because it's about rule of 72. And I normally don't talk about rule of 72, but the only reason I'm talking about it is because in accounting, generally, or some sort of, guided, uh, self-guided, how-to books like, something for dummy, right? Uh, they always mention rule of 72 as if it is some magical, you know, a formula or magical, method. But I'm trying to demystify that, mysticism about rule of 72 or whatever they so make so much emphasis in accounting or in books like something for dummies, right? Well, basically, the rule of 72 is simple. It's really, really, watered down method to find out how long it's going to take to double your money, double your investment. So for this example, let's take a look. You have $10,000, right? And then provided that you have certain interest rate, and the interest rate is not found here, but it will be given, right? Given certain interest rate, how long is it going to take to double your money? See, doubling, if you put $10,000 into a bank or into an investment instrument, when it doubles, it's going to be $20,000, right? Times by 2, right? So basically what you see here is, I put it there, right? And then how many years is it going to take? Or you can, when the time is given, then you can do it vice versa. What kind of interest rate it will take to double your investment? I don't know why. This has got to be, okay. And rule of 72 tells you to figure out how many years it will take, you will need to divide the interest rate by, you will need to divide 72 by the interest rate. Okay? Of course, right now, in other words, the dividend is 72, and the divisor is the APR. But of course, it's not going to give you anything because APR is 0. But the idea is, of course, it's not doing that, right? It's not going to give you anything. And next question is then, why 72? Why? Out of all the numbers, why 72? And it's only an approximation by dividing it by 72. Here, 72, you see it is 72%, not 72. 72% is 0.72. But, then 72 is like, 100 times 0.72, right? So is it 72 or 72%? Look, if the numbers are already expressed in percentage, if everything is in percentage already, right? So in other words, in this example, the numbers are, you don't have to put it in percentage. If, let's say, let me copy this. Copy that and paste here. No. Copy the whole thing. Now the mouse is acting up. The mouse is acting up, and the I guess it's because of the battery issue. Okay, so if I bring it over here and suppose everything is already in, if the label already tells you the number down below is percentage, right? Then you can just simply, make these. You can express them just as, just number, right? Again, so because if you put 72 there, right, everyone will know, because it's percentage, that's 72%, right? Of course, whatever this comes out to be, it will be, also. Now, then why do you divide it by 70? Why do you divide 72 by the interest rate? Now let's take a look at actual calculation. So this is $10,000 principal, and future value will be in 5 years. We know the answer already in this case. 5 years. You want it to grow to $20,000 or twofold, right? Then what should be the interest rate? We know the formula for rate. Formula for rate is what? Future value divided by present value is 1 over n. So n is 5 because the compounding frequency is 1. So it's basically the same thing, but we will, because we have added additional columns for periodic rate and actual number of compounding. We'll first follow this because you have to always solve for periodic rate. So then n is in F12, but you cannot click it in because the formula is covering the cell, right? So I will manually type in G12, right? And then -1. And it's going to give you something. What happened? G12 over A12 raised to 1 over G12 -1. Why is it giving me this? G12 over A12. Oh no, this was G12. Something was. This has to be oh yeah, that's G12, correct? This is F12. I'm sorry, that was F12, right? There you go. We got the rate, and then since this is the periodic rate, and then annual rate. This is already annual rate because compounding frequency is 1. To convert it into annual rate, you will simply need to multiply it by m, right? Okay, then let's try so our rate is now given because it's pointing to this. Now, how many years is it going to take? Because now APR is given. Now you divide by this. Oops, it's not, I'm sorry. That was supposed to be, this is not in percentage, right? This, but you know, when you divide this by this, no, it's going to automatically find it as, you know, percentage, right? But actually, too many digits, so I'll decrease. Yeah, use only like, you know, 2 to 3 decimal places. So what does that mean? 4.84 years, which is an approximation, right? Approximately, it should be exactly 5 years, but approximately 4.842. Now, another way we can use rule of 72 is, so time is known, right? So you want to grow your principal twofold in about 4.82 years. What should be the APR? Then using that formula, right? The formula is what? I mean, rule of 72. I mean, the actual formula, you know, actual formula. We can do better with the actual formula. We know how to do that. But by using rule of 72, if you divide, you know, 72 by APR, then that gave you time. Then if you divide 72 by time, then that should give you the APR, right? So divide that by, we'll give you something like, you know, right? Still, but if still this is, you know, it will give you exactly that because, you know, you divided that by 4.842, which was the result of dividing this by this. But what if this is 5, you know? So roughly, you want to double your money in 5 years, then what should be the interest rate? It gives you a rough approximation only, right? Gives you a rough approximation. And if it was a problem about finding, you know, we know how many years it will take if the interest rate is 14.87, right? First, we will find how many compounding frequencies, right? Of course, in this case, it's the same thing because our, you know, our compounding frequency is 1. In other words, it's annual compounding. So basically, the formula is natural log of future value over present value divided by natural log of 1 plus, in this case, R, the periodic rate. And you might, you know why periodic rate is the same thing as APR, because the compounding frequency is just annual. So in this case, it's the same thing. And it will give you 5. And then converting that into years is simple. That's 5 compoundings, right? 5 periods, and you divide it by m. That gives you 5 years. But it's all it makes difference when the compounding frequency is 4, like quarterly compounding, right? We all know already there will be 20 compoundings, right, over 5 years. And if you find the periodic rate, and you don't need to do it again, you simply paste it, right? Copy and paste. Then what does that mean? Periodically, so quarterly is going to be 3.53. And if you convert it into a annual rate, which is simply quarterly rate times 4, you see, and this conforms to what you have learned. The higher the compounding frequency, the APR doesn't have to be that much, right? Because higher compounding frequency takes less return, less rate of return to achieve the same goal. Now, finding n, also you don't have to do this again. I'm gonna simply copy formula for n and paste it here, and we get, of course, it's going to take 20 quarters, right? And then if you divide that by quarters, 4 quarters per year, then it's going to give you 5 years. So that's why that's how we should do it, actually, rather than using rule of 74. But why rule of 74? Why? It's because '72 is actually the result of, now let me use, okay, now think about it. If the investment is doubled, what does that mean? The ratio between future value and present value is 2. Isn't that right? Oh, why is it doing this? Yes. That means it has to be 2. In other words, right? Actually, it's natural log of 2, because this numerator has to be natural log of 2. Why? Because if FV equals 2 times the principal or present value, right? Right? Why is it giving me this? If that's the case, then of course the ratio between the two, then it's quite obvious. FV over PV is 2. Makes sense? That's doubling your investment, right? So our question is then, we take the natural log of 2, and natural log of 2, if you do that, actually you will find it's something like 0.6931. and dot, 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 right? Now, so I found, this is, I found natural log of 2 here, right? And then natural log of 2 is 0.69 something something. And since, the cell is formatted as percentage, it's giving you percentage. And so they approximated to 72. Why? Why out of all the numbers? I mean, was 69 or 70, 71, weren't they good enough? Look, 71 is obviously a prime number, right? And 70 only, rather than 70, 72 has, rather than 69 or 70, 72 has more divisor. There are more numbers this can be divided by, right? So they picked 72. So this is because this is the background, the origin of rule of 72. But this rule, but if there is a rule like that, rule of 72, what if you want to triple your money, quadruple your money? Yeah, all you need to do is, find, natural log of 3, natural log of 4, and find an approximated value. But then this doesn't work that well, right? Why? It becomes, inaccurate and unreliable. So then that's why you don't hear anything like rule of, 112 or rule of, 138, right? Why? Because, think about it. If it is triple, right? Suppose, doubling the money, right? What if it is, tripling the money, right? No, I'm copying this. Copy and paste it here. Okay, if it is annual, it's going to be like that, annual compounding. Again, if you copy this, paste here, right? So you want to triple your money in 5 years. The interest rate that will take you there is 24.57%. And if you have, if the prevailing market rate is 24.57, it will take you 5 years to get there. But then think about it. So if you know the rate and find, years using, approximation of log of 3, natural log of 3, then it becomes only like this. And using, if you have timeline of 5 years and divide 112 by this, then APR becomes very, unreliable. I mean, inaccurate. Also, even quadrupling your money. So natural log of 4, approximation, it's almost, that number, not approximation. But then, if APR is, actually this would be the APR to triple your money, and then over 5 years. But, then if you use that rule, if you use, something like rule of 138, then time becomes very inaccurate. Also, if you want to grow it, quadruple it in 5 years, APR becomes this inaccurate. So that's why rule of 72 is, only uh, a particular case, and it's still an approximation. But so they talk about it as if, this is some kind of, holy grail. That is a stupid thing, really. And accounting does a lot of, I don't know, accounting wants to make teaching accounting. I'm not a, accounting professor, and it's a different, uh, but, all the accounting departments on a very low level, like 101, they want to water it down. Like, in other words, accounting doesn't teach you how to think. They just teach you, how to follow mindlessly some procedure. Of course, on a higher level, it requires a lot of thinking. But I don't know. It's just the promotional aspect of accounting. They want to make accounting more approachable to uh, a large audience. So they make it, something for dummies. And they like to make it something for dummies, right? So what's more important is not what rule of 72 is, but how and why it came about, how it works. In other words, why it works. It's pointless just to memorize to divide 72 by rote. It's more important why the dividend is particularly 72 and not anything else, and why divided by the rate. To know this, it's inevitable to introduce the concept of compounding, the properties of exponent, and the logarithm. Otherwise, you are just watching a demonstration of how to turn on and off the light switch without why and how it works, without the theoretical background, in other words, mathematical background and logical reasoning behind it. You don't know how to fix when something goes wrong. And you can't tweak even a little, like how long it will take to triple or n-fold your money for a related example, right? If you don't understand how the electricity and its wiring works, you can end up trying to fix the light all the while leaving the cut knife switch on, right? Makes sense? So I've looked up, let me stop sharing this and let me share my entire screen, and let's hope. So there's, on Google, you can look up, right? You can look up a couple of, I've listed good links about, rule of 72. And the bad links, this is a very good example of a very bad link. Why? Very bad video. Why? Because oops. This video is the typical example of just showing you what you put into the black box and what comes out, without explaining what is happening inside a black box and why it works, right? So this type of video, I'm gonna. I don't recommend. I don't recommend. I don't recommend this video, right? I'm only showing you this video as a bad example. Why? Because in the comments, some people, this is really ridiculous. Some high school senior or junior wrote, I don't know where it is. There was something here, but I cannot find it. maybe top comments, sort by top comments. Yeah, and look here. Smart Joe, 10 months ago, posted, I'm a high school senior. I never heard about this rule before. Something is wrong with the educational system. Look, don't blame educational system. It's you. You're not that smart, Joe, huh? You must have learned, if you're a high school senior, you must have learned some algebra at some level. Huh? You didn't pay attention in algebra class, probably, and you simply, or it's not your fault because you mindlessly, think this is a good demonstration, right? This video is not telling you anything about why it works, why 72 in particular. It's just, there's no causality, no explanation of what causes this, cause and effect. It's just, input and end result, input and result. This is not a good math, right? This is not anything conducive to making your brain smarter. This is rather making you conducive to getting you hooked onto a GPS like a robot, right? I've been telling you about, why people are, becoming more and more mindless as they, get more and more hooked on to the GPS. You don't think, you don't have a mental map. You just, react, just, to the GPS prompt like an automaton, like a robot. Okay, so this is the problem of so let me stop sharing that video and let me go back to so this is, as I said, an optional lecture, but rule of 72, I just had to address this issue because they are not demystifying. I'm in accounting class, very low level accounting classes, and some, this market trend that tells you that kind of glamorizes these self-learning courses like something for dummies, glamorizing instead of demystifying something like rule of 72. Okay, so as I said, if you really want to dig more into it, I've posted a file with a list of good YouTube videos about rule of 72. Okay, alrighty. That's it for this segment of video. That's it for this lecture. Thanks for watching. Stop recording.